We're going to jump into taking some more derivatives and learning how to take derivatives of inverse trigonometric functions. But before we do that, we need to kind of review. And we've been talking about, and we reviewed what it meant to be a function and a function to have an inverse. And we also reviewed that if we took the composition of a function and its inverse, and it didn't matter order in this case, that we would get back x. We also know that in order for a function to have an inverse, it has to be a one-to-one function. If you look at the pictures here, we have pictures of your trigonometric functions, and none of these are one-to-one. They don't pass both the horizontal and vertical line test. And so in order to make them one-to-one, we have to limit the domain. And so in here, you can see the red part of the graph. That is what you're going to limit your domain for each of these trig functions in order to be a one-to-one function. And so the domain of our sine function, that has to be between negative pi halves and pi halves. If you look at it for cosine, to make this one-to-one function, we had to limit our domain between 0 and including and pi. Tangent, that was between negative pi halves and positive pi halves. Cosecant. So here it's really negative pi halves, comma, and then we're going to 0, 0. It actually can't include 0 because that's an asymptote. Union, if you want to write it this way, 0 to pi halves. Okay, so we can continue on with those. So for secant, this is going to be, it's going to include 0. And we have a asymptote at pi halves. So don't include it, put that parentheses, union pi halves to pi. And cotangent, again, this has an asymptote in there. And so we're going from negative pi halves, including, to 0, not including. And then from 0 to pi halves. Okay, so limiting our functions down like that, we now have a one-to-one function. And one-to-one functions have an inverse. And so now we want to look at finding inverse functions. So remember that our function and a function's inverse function, the domain and the range are swapped. And so if we look at the following would give us the graphs of our inverse function. And this is just quick review of trigonometry. Now we can't say it, trigonometry. There we go. So swapping our x and our y value and regraphing it, plotting our points and changing our domain and range. So remember with cosine, the range was -1 was the smallest value and 1 was the biggest value. Well, now for our inverse function here, our domain is what our range was for the original. And we had limited the domain for the original function from 0 to pi. And then swapping the x and y values, you will get a graph that looks similar to this, or you would get this graph. And so we did that case, the picture shows that case, swapping x, your range and domain, and replotting it. These would be the graphs of your inverse functions. So you need to remember and keep this in mind when domain and range, when we're looking at evaluating inverse functions. And so you really do need to remember this unit circle here. And so, because we kind of think backwards. So remember that on the unit circle, our x point was cosine of theta y value was sine of theta, where theta is the angle. So for instance, cosine of 30 degrees or cosine of pi 6, that is going to give us back √3/2. Where if we were looking at the sine of theta, that would be looking at sine of pi 6, which would give us back this 1/2. Quite a quick review. So you should be able to find each of the following without a calculator or the unit circle. So for example, let's say you wanted to find sine inverse of 1/2. So basically we're thinking to ourselves, sine of what angle theta gives us back 1/2. So I know that sine of 30 degrees or pi 6 so sine inverse of 1/2, this would equal, and they want it in radians, so pi 6. There's two values though that would have given us back sine, there's two angles that would have given us back positive 1/2. The thing is that we had to limit ourselves to just quadrant 1 for the positive values. Any value that's negative, so if this had been sine inverse of negative 1/2, and we wanted to figure out what that's equal to, we have to think about our reference angle, and we have to think about what is our domain for the inverse function. So in here, sine inverse, we had to limit that domain between negative pi halves and pi halves. So I really know that, again, if I just think about it with a positive, sine of 1/2 is equal to pi 6. But to get this to be negative, I need to be in quadrant 4. Remember negative angles, that gave us, it went clockwise versus counterclockwise. And so if I just started at my 0 and went negative pi 6, so this has to equal negative pi 6. Okay, so let's go through a couple more. So if we were looking at cosine inverse of, how about negative √2/2? I know my output of this was the domain of my original function. For cosine, the original function was from 0 to pi. We limited our domain to 0 to pi. So this answer has to be between 0 and pi. So the first and the second quadrant. I know cosine is negative normally in the second and third quadrant, but I'm only worried because of the inverse function, the second quadrant. To me, I always think about it with a positive first. So I would think to myself, what is cosine inverse of √2/2? What would that angle be that would give me back √2/2 for cosine, which I know is 45 degrees or pi 4. But this is just my reference angle, and I have to get this value into my second quadrant. And so recall, this is where you would look at, this is pi, our reference angle is pi 4. So we want to go up here, pi 4. And so to get this angle in here, I could look at this as pi minus pi 4. which is 3 pi fourths. So this angle in here is equal to 3 pi fourths, which is an angle between 0 and pi. So our result, cosine inverse of negative root 2 over 2, this is equal to 3 pi fourths. Okay, so some of your homework is just a review of inverse trig functions, finding that. And here's another little bit of review before we go and prove how to find your inverse, the derivative of your inverse trig functions. So let's say you had the following. Let's say it was secant of cosine inverse of 1/2. So it wants us to find these values without using a calculator or the unit circle. So we want to work the inner piece and outwards. And so we first need to figure out what is cosine inverse of 1/2. So I'm thinking to myself, cosine, what is that angle that gives me back 1/2? So that would be at 60 degrees, which is pi thirds. Theta here is pi thirds. So let's rewrite this. This is the same thing as secant of pi thirds. So if you don't have secant memorized, you should really just have as long as you have cosine and sine memorized of these angles, you can always get the other ones. So if you don't have that memorized, we can rewrite that in terms of cosine. This is the same thing as 1 over cosine of pi thirds. Well, cosine of pi thirds is 1/2. So this is 1 divided by 1/2, which is the same thing as 2. So what if it was cotangent of sine inverse of negative root 3 over 2? So again, we want to work in the inner piece first. So we want to figure out what is this sine inverse. And I tend to, like I said, first figure out the positive. So what is sine inverse of positive root 3 over 2? So that is 60 degrees, or pi thirds would get us to positive root 3 over 2. But we're thinking of this, we're in our sine inverse for the negative. This has to be in, so this is a reference angle in quadrant 4. And it had to be between negative pi halves and pi halves. So that would be negative pi thirds. So this right here is negative pi thirds. So we have cotangent here of negative pi thirds. And again, if you don't remember cotangent, we can rewrite this in terms of sine and cosine. I know that this is cosine of negative pi thirds all over sine of negative pi thirds. So multiple ways I can do this. I can think of this as even and odd functions. And I know cosine is an even function, which means that f of negative x is the same thing as f of x. So this would be the same thing as looking at cosine of pi thirds. And sine of negative pi thirds, well, sine is an odd function. So that was f of negative x equals negative f of x. Pull the negative out. So this is negative sine of pi thirds. Or you could just think of these as reference angles, what it would have been in the fourth quadrant there for sine and cosine. So this is 60 degrees. This is going to be 1/2 divided by negative sine of pi thirds. Sine of pi thirds is the same thing as negative √3/2. So invert multiply. So 1/2 times negative 2/√3. 2's cancel, we get negative 1/√3. Rationalize our denominator, we get negative √3/3. So we want to now look at the derivative of your inverse functions. So that was just a review. Now we're getting into new stuff.